All right. We are asked to calculate the area of the shaded part. And if we look at the compound figure we have, this happens to be a square because all the sides are equal. And then the shaded part happens to be the semicircle. So what we are asked to look for is just the area of the semicircle, which happens to be the shaded part. Now I can split this figure to have something of this, nature. Why this happens to be the shaded part, which is the semicircle, and from here to here being our 14 cm. This is a semicircle, and we have to get the area. The area of a semicircle is given by the area of a circle, that's by r squared, all divided by 2, because a semicircle is half of a circle. And the distance from here to here being 14 cm happens to be the diameter of the semicircle, because the radius is just the distance from one point to the midpoint. And this is a distance that covers the circumference of the circle. So our radius will be the diameter divided by 2. That would be radius is equals to the diameter all over 2, giving me 14 cm divided by 2, which is equal to 7 cm as the radius. Now let's slot in the values and get the area. And that will give me my pi is always 22 over 7 times my radius, which is 7 r squared. That's 7 times 7, all divided by 2. The 7 we cancel 1 7. I'm left with my area is equals to 22 times 7, all over 2. 2 divided by 2, 1. 22 divided by 2 will give us 11. I have that my area is 11 times 7, 77 centimeters square. So the area of this shaded part is equals to 77 centimeters square. As simple as that. Okay, this is another figure that we have with us. We're asked to get the area of the shaded part. If we critically look at this figure that we have, we'll see that we have a triangle and then a rectangle. Yeah. And if we're then to get the area of this shaded part, that means we'll have to get the area of the triangle and then subtract the area of the rectangle from it to be able to get the area of the shaded part. That will give us something of this nature. I have that area of shaded parts is equals to the area of the triangle minus area of the rectangle. And that'll give us area of triangle is half base times height. While the area of a rectangle is length times breadth. And that will give us for the this area of the shaded parts. We'll have area of shaded part is equals to 1 over 2. The base of the triangle here is 12, and the height is 9 minus The length times breadth of a rectangle, that's 3 times 2. I'll be having something like 2 into 1, 2 into 12, 6. 9 times 6 should give us 54 minus 6. And I'll be getting something of 48 centimeters square. So the area of the shaded part is 48 centimeters square. Find the area of the shaded part. In the figure, we have two same figures, which are rectangles and then a mini rectangle. And we're asked to find the area of this empty space, which is shaded. How to get that? We need to know the area of this bigger figure and then subtract it from the area of this smaller figure, and that will give us the area of this um, space here, which is the shaded part. Okay, let's area of shaded part equals to area of big triangle. I mean, use capital letter B for the big rectangle, sorry, minus area of small rectangle. Area of a rectangle is the length and breadth, capital letter L and capital letter B for the bigger triangle, and then small letter L times small letter B for the smaller rectangle. That will give us, for the big rectangle, we have it to be 9 times 8 minus, how do we get the length of the smaller rectangle? Remember that 1 meters has been taken off here, and 1 meters has been taken off, leaving us that 2 meters has been taken off. I mean, for these 8 meters, 1 meter has been taken off, 1 meter has been taken off, leaving us with a remaining distance of 6 meters. So here I'll have it to be 6 times. Here also, 1 meter has been taken off, one has been taken off, leaving us with what? 7. So here should be 7. And we'll have it to be 9 times 8 will give us 72. Minus 6 times 7 will give us 42. Subtracting the 2, I'll have 30 meters square. And that is the area of the shadow part. Equals to 30 meters square. There we have a right angled triangle, and then we are asked to find the value of the longest side being the hypotenuse with the value x. Find the value of the x, which is the value of the side. Now here we are going to apply the Pythagoras rule that says that if we square the hypotenuse, it will be equivalent to the adjacent c squared plus the opposite c squared. This is the Pythagoras rule. And then applying that, we'll have that the hypotenuse happens to be the longest side of the right angle triangle, which is the x r squared. Our adjacent can be any of the sides. Let me pick it as 6 squared plus my opposite, x squared. Now the x squared will give me 36 plus 64, giving us a value of 100. From here I can find the square root of both sides and have that my x squared in square root will give me square root of 100. How that my x is equal to 10 cm. That's the length of that longer side. We also evaluate 50.32 times 0.0003. The easiest way of doing this is just to convert each of the numbers to standard form and then multiply. I have something like changing this to standard form. Let's change it to whole numbers. Or standard form is going to work. Yeah. This will give me 5.032 times 10 to the power of 1 because I'm moving left, then times move right 1, 2, 3, 4. That's 3.0 times 10 to the power of negative 4. And then multiply the numbers. I have 5.032 times 3 times 10 to the power of 1 times 10 to the power of negative 4. This times this will give me 15.096. Then times applying the laws of indices here, I'll have that this is 10 to the power of negative 3. 1 minus 4 will give us negative 3. And then changing from standard form back to ordinary number. I'm going to move backwards 3 times because there is a negative 3 there. And that will give me, let's say, 15.096. Moving 3 times backwards, that will be 1, 2, 3. Add a 0 here, and this 1 point here. That will give me 0.015096. Now, I can be asked to round up the answer to, um, let's say, 3 significant figures. The 1 here happens to be the first significant figure because it is the first non-zero number. The 5 here is the second. The 0 here is the third because it is in between 5 and 9. Zeros in between numbers are considered to be significant. So this is the third significant figure, and that's where we're asked to round up to. I'll put my line at the back of it and then approximate. Now give me 0.015. This number here is equals to 5. Turn it to 1 and then add 1 here. That will give me 1. That's the 3 significant figures. That's my answer.